Good afternoon, students. In the previous session, we were studying about center of mass. And we have studied what is center of mass, what is the need of center of mass, and how to locate the center of mass. These things were done. Now, the last topic of the previous class was center of mass, or you can say center of mass of continuous mass distribution. That was the topic. And there we were discussing about some mass densities, and I was discussing the linear mass density. That was mass per unit length of the body. Now moving further for today's topic, I think we should wait for some time. In fact, 1 minute, I will wait. And after that, I will continue the session. Okay. So now moving further, we have surface mass density. If you have any doubt, you can ask me in the chat box, and I'm continuously monitoring the chat box now. Okay. So surface mass density, it is denoted by sigma. It is denoted by sigma. So JNV Pune. You missed the yesterday's class actually. Have you seen it on YouTube, or you just skipped it? Let me know in the chat box actually. Or should I repeat some previous work? Am I audible? Okay, you have seen it from Zoom, JNV Pune. Okay. So now, okay, okay. No issue with that. No issue with that. You can ask me if there is a doubt. You can either raise hand, or you can just chat me, text me in the message. Okay, sure. So now, previously we have discussed center of mass. I will give you a glimpse of the previous portion. Like this was the work we have done. So these are the basic formulas that you need to remember. I will let you know in the further classes. Like what we need today is this one. Either you can take a picture of this or anything. We are going to discuss from here only. Okay. So let me clear one thing. Surface mass density is like if you have a body which has a mass on its surface. For example, if I say this body has a mass on its surface only, if its thickness is ignored, then what I say, surface mass density is mass per unit area. Mass per unit area. So sigma is defined as mass per unit area, and its unit will be kg per meter square. I think there is no issue with that unit. Mass per unit area. So what is the need of these quantities? What is the need of sigma? For example, this is just an example. What is the need of this sigma? If I say you have a rectangle or you have a square sheet of side A, you have a square sheet of side A, and the mass density of this sheet is sigma. Mass density of this sheet is sigma, and you were asked to calculate the mass of the sheet, total mass of the sheet. Then can you say that mass per unit area is sigma and the total area of the sheet is A square? Then mass of the sheet will become sigma into A square. What we did? Mass is equals to sigma into area. Mass is equals to sigma into area. Sigma is the density. Area is what? A square. So if we know the mass density of the body, we can calculate the mass of the portion, mass of the total body, we can calculate. Similarly, if mass is distributed in a body in a volume, then we can use volume mass density, and which is denoted by rho. And definition will be mass per unit volume. And you can write in terms of formula, rho is equals to mass per unit volume. If I ask you one question, what will be the unit? You will say unit is mass is kg divided by volume is meter cube. Unit is this one. If I ask you one thing, that you have a hollow sphere. You have a hollow sphere. Like this one. This is a hollow sphere. Which mass density will you use? Surface mass density or volume mass density? Which mass density will you use? Either sigma or rho. This is a sphere. Solid sphere, nahi, it's a hollow sphere. Which mass density will you use? Answer me in the chat box. From YouTube, persons watching on YouTube can also answer. Okay. This is a hollow sphere. Mass is only at the surface. So you will use surface mass density, which is sigma. You will use sigma. You will not use rho. Because rho is for what? When mass is on the volume, like solid sphere, mass is on the volume, then you will use rho. I think these things are sorted. Now, the students who haven't watched the previous session, I request them to please watch it on the YouTube. Okay. So now, what we need to do, we need to locate the center of mass of a thin rod. We need to locate the center of mass of a thin rod. Just try to learn, and I hope you will get everything. First of all, let me draw a small thin rod. Let's suppose this is a thin rod. And this thin rod has a mass m and total length of L. This is our y-axis and this is our x-axis. Try to summarize things in your mind. Try to learn the step, what we will do here. Okay. What I need to do, I need to locate the center of mass of this rod. The thing is, first step says choose a small element on the rod. Choose a small element. I have told you yesterday in yesterday's session. Choose a small element. I have chosen this small element, very small element of length dx at a distance x from the origin. At a distance x from the origin. I think this point is clear to you. Now, if this element is small, its mass will also be small. Let's suppose its mass is dm. What is dm? Dm is the mass of this small element. This is a general practice. You will do a lot of time these integration things, these elemental things. You will do a lot of time in the physics. So try to understand it here only. Dm is the mass of this small element. What I am saying, what will be the mass of this dm? What is the value of this dm? Dm is what? The mass is distributed on the length. Mass is distributed on the length. So you will write dm is equals to lambda into dx. If this thing is not clear to you, I will tell you, have a look at that. What is linear mass density? Linear mass density is what? Mass per unit length. So mass will be lambda into length. Length is what? The portion you want to calculate the mass, that length. So here I want to calculate the mass of this small portion and length of this portion is dx. So the mass is lambda into dx. Lambda is what? Mass per unit length. Mass of the rod is m, length of the rod is l into dx. This is what? dx. Now, locate the center of mass. X coordinate of center of mass will be integration x dm divided by integration of dm. This is the formula that we have studied. You can remember it very easily. What is dm? Dm is the mass of the element. X is the center of mass. Yeah, position of center of mass of the small element. Again, dm, integration dm means total mass. This term is what? Total mass. So I will put the values of dm here. So x center of mass. What is the meaning of xcm? X coordinate of center of mass. So after putting the values, I will get integration x. This distance is x. Its mass is m by l dx divided by total mass of the rod is what? Capital M. Can you see that m will cancel out? This m will cancel out. So what will happen? It will remain length 1 by L. L is taken out from the integration. Integration x dx. So what is the limit of this integration? This limit of this integration is from end A to the end B. And end A is what? At a distance 0 from the origin. And end B is at a distance L from the origin. If you integrate it, it will become 1 by L. X integration is x square divided by 2. Limit is 0 to L. So it will again become xcm is equals to 1 by 2L. Upper limit minus lower limit will tell us L square minus 0. L will cancel out. X coordinate of center of mass will be L by 2. What can you say here? You can say that center of mass of a uniform rod L by 2, can you say it's the center of the rod? Total length is L, then L by 2 is the center of the rod. So you can conclude that Center of mass of a uniform rod is at the center. Is at the center. I think these things are clear to you. Okay. First step. Now let me summarize these things because we are going to do it in greater detail in the next section. First thing is choose an element of a small choose an small element. After that, you need to find the mass of that small element by using either linear mass density. If mass is distributed on the surface, then you can use surface mass density. Whatever the situation is, you need to calculate the mass of the small element. Next, you need to put the formula for x coordinate and y coordinate. These are the simple steps. Okay. Now moving further. Now there are some special things. Center of mass, some symmetrical bodies can be remembered very easily. Some symmetrical bodies means like there is a ring, it is a symmetrical body. Mass is uniformly distributed for a symmetrical body. These bodies, symmetrical bodies, have center of mass at their geometrical center. At their geometrical center. You can remember this thing. For example, if this is the ring, then its center of mass will be at its center. If this is a solid sphere, for example, if this is a solid sphere, then its center of mass will also be at its center. This is a rectangle, its center of mass will be at its center. Symmetrical bodies have center of mass at their geometrical center. This is a cube or cuboid, its center of mass will be at its center. Sorry. I think these things are clear. Moving further. Now, okay. So, center of mass of a semicircular ring. Circular ring has the center of mass at its center. That I have told you. Uniform bodies. But what about a semicircular ring? Semicircular ring will look like. Can you say that this is a semicircular ring? It's not very much proper, but yeah, it's a semicircular ring. This is the center of the ring and radius of the ring is R. Clear to you? And the mass of the ring is capital M. Clear? Now tell me one thing. The mass of the ring is distributed on its surface, on its length, or on its volume? Just answer me this question. Anyone who wants to answer? I'm also checking YouTube. Okay. No issue. Ring has what? Ring is just like a rim. It has only length. So mass is distributed on its length only. So let's suppose this is our origin. Let's suppose this is our origin. This is our x-axis and this is our y-axis. Can you see one thing? That this ring is symmetrical about y-axis. Listen to me very carefully. The portion to the left of the y-axis is same as the portion to the right of the y-axis. Can you see that? Then in that situation, center of mass will lie on the y-axis only. It will not lie on the x-axis, or anywhere on the x-axis its component will be 0. Repeat, I am repeating it once again. If a body is symmetrical about any axis, then its center of mass will be on that axis only. Clear? Okay. So now, what we need to do, first step, we need to choose a small element. So let's take a small element. And the condition was the small element can move around the body. If you pull its legs, it can move around the body. I have told you in yesterday's class. So let's take a small element. Let's suppose at an angle theta and another at an angle, another very small angle d theta. If you can't see, I will write it separately. This small angle is d theta. D theta. So our small element is this one. A, B is our small element. By changing the theta, you can move the element on the entire ring by changing the theta. If I increase the theta, this element will be here. If I increase theta further, this element will be here. So by changing the angle, I can move around the complete circular or semicircular ring. That's what the idea behind it. Now, main thing is the element should be should be chosen in such a way that it can cover the entire body whenever required. Okay. So first thing is completed. Second step, let's take its mass as dm. Take its mass as dm. So how will you calculate dm? I have told you dm is what? Mass is distributed on the length, on the circumference. So we will use lambda into length of this small portion. Length of this small portion. Let's suppose dx. Then can you calculate the length of this small portion? Length of the arc, you know the formula. I think you know the formula. Length of the arc. Arc length is equals to theta into radius. Is it clear? So dm is equals to lambda, and dx is what? Arc length. Arc length is what? Radius r into this small angle is d theta. You can say yes or no if you are getting this dx length. What is this dx length? This dx length is the AB. AB is the length of the dx. And this is what? This is the arc length. And arc length can be calculated as, for example, I will give you an example. For example, this is a circle. This is the radius. And this arc length L is what? R into theta, that you have studied. But in our question, theta is what? D theta. So that's why we have written dx is r d theta. I hope this thing is clear to you. Now moving further. Okay, we have calculated dm. Now applying formula, x coordinate will be 0, y-x coordinate will be 0, body is symmetrical about y-axis. So center of mass will lie on the y-axis only. So y coordinate of center of mass will be integration y dm divided by integration of dm. I hope these things are clear. What is y? Y is the y coordinate of center of mass of the small element. This small element has the y coordinate, this one. Okay, y coordinate of this center of mass will be like this one. So you need to find this height y. In the right angle triangle, for example, I will write it P. In the right angle triangle OPQ, can you find y? Can you find y? In right angle triangle OPQ, y is what? Perpendicular. Perpendicular is what? Hypotenuse into sine theta. Perpendicular is what? Hypotenuse into sine theta. I think these basics are very much clear in your mind now. Okay, so now putting the values. Y coordinate of center of mass will be integration. Y is what? R sine theta. dm is what? You can also put the value of lambda here. Lambda is what? Mass per unit length. Mass per unit length. What is the length of the semicircular or of the circumference? You will say this is semicircular. Semicircular means 2 pi r is the total length. Then this length is pi r into r d theta. R will get cancelled out. So dm is what? M by pi d theta. This is what? dm. dm is m by pi d theta. So I will put the value of dm m by pi d theta. Clear? Divided by dm integration. Integration dm means total mass. And total mass is what? M. Now we need to integrate it. Just integrate it. You can see that this m will cancel out. So ycm will become, r is the radius which is constant, pi is a constant, they will come out of the integration and it will become r over pi integration sine theta d theta. Now another aspect came. That aspect is, what are the limits? What are the limits? Just have a look at the small element. I have told you that if you change the angle theta, then it can cover the entire body. One element has one line OA and another line OB. Can you see the diagram? It has one line OA, other line OB. If you put this line OB to cover the entire body like this one, so OB will come here along the x-axis. So theta will be 0. And to cover the, you will, if you pull the another leg OA, it will reach at this point. So this angle will be 180. This angle will be what? 180. So the limits will be 0 to 180. 180 is what? Pi. You can integrate it now. R by pi. Sine theta has an integration minus cos theta 0 to pi. I can put this minus sign here. It will make it positive. If you put the limits, you will get y coordinate minus r by pi cos pi minus cos 0. Cos pi is minus 1. cos 0 is 1. So it will become minus r by pi minus 1 minus 1. This minus is cancelled. So YCM is 2r upon pi. X coordinate of center of mass was 0. Y coordinate of center of mass is 2r upon pi. 2r upon pi. You need to remember this result. It's a very important result actually. YCM is 2r upon pi. Is it clear to you? I know that this thing is quite lengthy, but if you have clear concept in your mind, you need to use these concepts very frequently in near future, in the upcoming future. That's what I'm saying, that you need to summarize these things in your mind. As your exams are approaching, you need to summarize these things. Okay. I will move ahead. Okay. So now, in the previous sections, I have done two derivations. I think one is this one, uniform rod. Another is uniform circular ring. Now, there is a question. If the rod is not uniform means its mass density is not uniform. What is the meaning of this non-uniform mass density? If you see this question, you were given a rod, thin rod, but you were given a mass density, linear mass density is lambda not x. That means as you move in the x direction, for example, this is the rod and this is our coordinate. This is our y-axis and this is our x-axis. And this is our origin. What I'm saying, if someone is moving in this direction away from the origin, x increases. What is the meaning of this increase in the x? Lambda will also increase. That means this portion, if it's not visible, this portion is lighter as compared to the portion ahead of it. Ahead of it is another heavier. The rod is becoming heavier as you move in the positive x direction. This is the meaning of this mass density. If I say this pen is uniform, has uniform mass density. This pen has uniform mass density, but there might be situations you will see that mass density can increase in certain bodies. If you put your bat in your hand, at one end it's heavier, other end it may be lighter, if you can see that. So now what we need to do, we need to locate the center of mass in this case. Okay, steps are very clear. First step is choose a small element. I have chosen a small element. A small element of length, what? Dx. At a distance of what? X. From where? From the origin. So what I can say, I have chosen a small element of length dx at a distance x from the origin. Then let its mass is dm. And can you notice one thing? The length of the rod is given to us, which is L. But the mass of the rod is not given this time. In the previous derivation, here the mass of the rod m is given, length is given, but in this question mass of the rod is not given. So we also need to calculate the mass of the rod. They have not given us the mass. So now question becomes very interesting. It's of JE level. So try to be in that presence of mind. Okay. I hope you are focused. Your focus is on your screen. Everything is sorted till now. And please watch the previous video. It will help you a lot. Otherwise, things will go like this. Like faded. Now, first step is we need to calculate the mass dm. What is dm? I have told you dm is what? Till now, you learned the dm? Lambda into dx. dm is what? Lambda into dx. Lambda is what? Lambda is given as lambda naught x dx. Okay. I am feeling like these things are pretty much not gettable to you. If you are getting some things, at least if you are getting 30% of what I am saying, then please write a yes. Otherwise, I need to repeat these things from the scratch, and we don't have that much of time. Actually, we have some targeted time period. So if you are getting 20 to 30% of these things after skipping the previous lecture, you can just say yes, and we are getting some part of it. In the future sections, I will cover everything. Okay. dm is lambda naught x dx. Done. So now next step is we will locate the x coordinate of center of mass. Is like this. Have you remembered the formula? Integration x dm divided by integration of dm. That's what we are using. If you are using y coordinate, then this x will be replaced by y, nothing else. Done? Okay. So now we will put the values. Here integration of dm is obviously total mass, but total mass is not given. So we will calculate that as well. Okay. It can be written as integration. X is what? Distance. Into dm is what? Lambda naught x dx. I am just putting the values here. This is what? dm divided by integration of dm. dm's value is lambda naught x dx. Lambda naught is the constant. It can be taken out from the integration. Lambda naught is the constant, can be taken out from the integration. And if I take lambda naught out from both the integrations, then it will cancel out. So why not cancel it out here? Now someone may ask, sir, x will also get cancelled. This dx will also get cancelled. Then nothing will be left. Only constants will get cancelled in this way. So what we have left, x square dx integration x square dx divided by integration x dx. Just reply me once whether do you know about the integration, the formulas of integration. I am putting these integrations very frequently, very without thinking about you. I hope you know the integrations, basic integrations. Okay. Now, what are the limits? We are integrating it about dx, and dx can be varied from, if I pull this and a and b, a can be pulled to here, b can be pulled to here to cover the entire body. So a is 0, b is L. So limit is 0 to L. 0 to L. Now if you integrate it, x square integration is what? X cube by 3. Integration is what? X cube by 3. Can I write it here? X cube by 3. Limit is 0 to L. Divided by integration of x is what? X square by 2. Limit is again 0 to L. You can put the limits. You can put the limits. What are the limits? Can you see this 2 will go there? So it will be 2 by 3. If you put the limit, it will be L cube and it will be L square. So x coordinate of center of mass will be 2L by 3. And what about the y coordinate of center of mass? Is there any mass lying on the y-axis? Rod is thin. There is no mass lying on the y-axis. If there is no mass on the y-axis, then center of mass can never lie on the y-axis. So the y coordinate is also 0. Similarly, can you say that z coordinate will also be 0? Because there is no mass on the z-axis. Mass is placed only along the x-axis. I think this thing is clear to you. If I say that time is almost done for now. Again, this is a simple question. This is a simple question. These two rods, I will do it. These two rods are identical. They have length 2L. This rod has length 2L and both the rods have same mass. What you need to do, you need to locate the center of mass of not the rod, of the system. You need to locate the center of mass of the system. So what is the system? System is the combination of two rods. You need to locate the center of mass of the system and the origin is given at this point. Now let me clear one thing. This point is the midpoint actually. From the diagram you can see that it's not mentioned actually, but it's given actually that this is the midpoint and this length is L, this is L. So this is again a very important conceptual question you can learn. Do you know that for a uniform rod, center of mass is actually at the center? Center of mass is actually at the geometrical center of the body. So can I say that center of mass is the point where all the mass may be assumed to be concentrated? So this rod 1 has its mass m concentrated at this point, and this second rod, this is the second rod, has its mass concentrated at this point. Are these points visible? Now again, if I write, this separation will be what? This separation will be what? You will say this is the midpoint, so this separation is L. This separation is L. So now what does this system look like? It looks like there is a mass m and there is another mass. I will draw it there. What you can see, this capital mass m and this capital mass m, they are placed at a separation of L. Now locate the center of mass. This is the what? This is origin. Can you see that these two masses are identical? These two masses are identical. So for identical masses, the center of mass is at their center. So is at their center means the center of mass will be at this center, which is L by 2, L by 2. I didn't even need to write anything to solve this question. What I have done, now what is the concept behind it? If you have a large size body, a continuous body attached with another body, what you can do, you can locate the center of mass of each part of the body, each part of the system. Consider it a point mass and then locate the center of mass of the system as a point mass system. For example, do you get this answer? Answer is what? Answer is what? Y coordinate of center of mass will be at a distance L by 2 behind the origin, or you can say L by 2 downward to the origin. So it will be minus L by 2. Clear? Y coordinate. X coordinate is 0. There is no part in the X direction. So what I have concluded, what I have told you from this question, what was my intention? For example, you were given one square plate, another square plate, another square plate. So you were given 3 square plates. Side A, every side is A. And you were asked to locate the center of mass of this system. So can you see that this system can be broken in 3 parts? 1 square plate, 2 square plate, 3 square plate. And we know that for a symmetrical body, the center of mass is at the center. So you will say that its center of mass is here. Center of mass of second plate is here. Center of mass of third plate is here. What is the meaning of center of mass? The entire mass of this first plate can be assumed here. This mass can be assumed here. This mass can be assumed here. Now, you have transformed the body, the rectangular or square sheet, into a point mass. And in the previous session, actually, we have studied in deep detail about the point masses, center of mass. Center of mass of the point masses, we have studied it in great detail. So I hope there will be no problem to locate the center of mass of this system. So this is the basic approach that you can learn. Now there are a lot of topics left behind in it, because center of mass is a very large concept. This is the basic fundamentals that you can learn from here. So I will end the session here. Thank you for joining and take care. Bye bye.